Oops. Dear friends, welcome back to the project Snow Queen. Today we're talking about physical principle of our novel refrigeration system. We discussed in previous videos how low temperature refrigeration is important to produce superior products and services in such critical industries as food, healthcare, and energy. Low temperature refrigerations from minus 30 to minus 200 degrees Celsius are provided with conventional refrigeration system. So how do they work? Well, two principles. First, compression of the refrigerant gas, and two, acceleration of this gas. So let me demonstrate you on how it works on a simple example. So imagine that this balloon is a conventional refrigeration compressor. Well, first we have to compress the refrigeration gas. So now when the gas is compressed, we can accelerate it, and while it is accelerating, its temperature goes down. So we obtain this refrigeration effect, and you can try it at home. So we start accelerating it, and this acceleration causes the cooling effect. Very simple. The only problem is that the lowest temperature that we could economically obtain with this approach is minus 50 degrees Celsius. If we want more, we need to compress this gas more in order to give it a chance to accelerate with higher velocities and therefore producing lower temperature. But let me demonstrate you what happens if we compress it too much. Oops, sorry for that. Well, what are you going to do about this? In order to get temperatures lower than minus 50 degrees Celsius, we need to use the second compressor. Well, and in this example, we could achieve temperatures lower than minus 50 degrees Celsius, about minus 100 degrees Celsius. Well, let me show you how this works. We first compress refrigeration gas in the first compressor. Then we do the same thing for the second compressor. So now we have two compressors, and we use the first one to provide the cooling effect in exactly the same way as I showed previously. But we use this cooling effect to cool down the second compressor. So it looks like this. We cool it down with the cooling effect. And now when the gas in the second compressor has a lower temperature than before, we could then accelerate it again, but this time the temperature will go lower. So to about minus 100 degrees Celsius. Well, very simple, isn't it? The only problem is now we have two compressors. This means double cost. We have to use 2 times more energy to compress gas in the second and in the first and in the second refrigerator, and also their interaction becomes more complicated because the chances that something goes wrong with two compressors are higher. Therefore, the maintenance cost also goes up. Well, okay, what about minus 150 degrees Celsius? Can we achieve that? Well, yes, and I hope you guessed it. We use the third compressor, and all these problems just multiplied by the factor of 3. And additionally, you also have to use greenhouse gases, very complicated refrigerant gases, in order to operate this complicated system and obtain temperatures below minus 50 degrees Celsius. If we need even lower, we use liquid nitrogen. Well, liquid nitrogen is produced in centralized, specialized facilities, and then is transported using sophisticated logistics system and equipment, and then has to be stored at the facilities of users of this liquefied natural gas. And all of this is just inefficient. Can we do something about it? Can we use a different approach for refrigeration in order to allow affordable cooling effect for superior products that we talked about in the previous videos?